I'm Benzing, Aircraft Commander of the B-24 LIberator Diamond Lil. It's my honor to be able to fly this aircraft on tour, take it out to people to let them see, get an idea of the history of the aircraft and the crews that flew it. Just a little look around the aircraft. It is manual control, meaning it's fly-by cable. Everything is manual. We have control yoke, for example, comes way back for landing. A lot of throw to aileron, so that's somewhat unusual compared to most aircraft. Similarly, the rudders have a large throw to it, all of which kind of add up to making it a little bit more difficult to fly the aircraft than the average airplane. We also operate without the benefit of nose wheel steering, so we use engine power and braking to steer on the ground. The setup is we have propellers on the left on this aircraft, throttles on the right, mixtures, throttles in the center and mixtures on the right. Engine instruments are dual instrumentation, so you've got 1 and 2, 3 and 4, 1, 2, 3 and 4, propellers and engine power respectively. Then of course the regular engine gauges. This portion of the aircraft is essentially original. The flight instruments are somewhat updated, although rather old by today's standards. This being a very early model, has a very different setup than some of the later model B-24s, which had turbochargers and a lot of additional equipment put in. So if you go from this to a J model, you'll note quite a few differences. We have hydraulics for gear and flaps and brakes. We have standby electric pump to power hydraulics if we need it. And on the sidewall you may see that we have a hand pump with a series of valves that serves as another backup to the hydraulic system. Electrics is only used for radios, starters and such. It's not used for any of the major components. So it's a very basic airplane. It performs fairly well, but certainly has its idiosyncrasies. On the overhead panel we have the starters, boost pumps, pre-oilers and so on, magneto switches and feather buttons. And of course we've got a young lady on the dash we call our turbulence detector. Wiggles nicely when we hit the bumps. On the aft pedestal we have the rudder trim, 2 trim wheels for elevator, and we do quite a bit of trimming. It's quite heavy in pitch, and aileron trim. We also have a gear handle which goes directly to a hydraulic module. I usually wear gloves when I actuate it because it's somewhat difficult to move and bangs back when it has completed the cycle. Similarly, the flap handle is a direct to the hydraulic module. I've opened the door here for our nose wheel, where you can look down to see whether your nose wheel is turned. It's not particularly useful for determining whether the gear is latched, but you can get some general information just by looking down. And the control lock is right here. We taxi with the control lock engaged. And we do that because the rudders are not very effective on the ground, and it's very difficult to taxi when the rudders are moving all about. Okay? So when we lock it, it locks the elevator, rudder, and aileron. Pull down the strap to latch it in position, make it much easier to handle the aircraft. Then we'll walk to the flight engineer's position. He doesn't have a regular flight engineer panel that you might expect, but he has the basic systems back here in a number of ways. Let me get out of on the other side here so you can see this a little better. We have the electrical system here where you have the generator field and generator switches, and along the top engine interrupter switches, which allow us to cut out the starter and so on, remove power from the engine nacelles. Also our lighting is up here. On the lower panel we have a hydraulic pressure gauge We have the fuel shutoff valves, which normally are selected tank to engine, but we can also use this for cross-feeding fuel. Crank to lower the main landing gear in an emergency, and we have a separate procedure for the nose landing gear. And we have engine fire bottles. There's not engine fire detection, but there are fire bottles, so once you think you have a fire, you can use those. We have the hydraulic cabinet, which contains about a 7-gallon reservoir and a lot of our materials, and this is where it feeds our hydraulic system for the gear and brakes.
This aircraft required an engineer as opposed to modern aircraft?
It always had a flight engineer, as much for having someone very familiar with the systems, maintenance, fueling, and so forth as anything else. But he was also the backup guy for watching your engine instruments, limits, and so on. And we use him in a similar fashion. He reads a checklist back here, and he is standing here watching our gauges while we go, so he's a great set of eyes for us. During taxi, he'll actually be up looking out the top, giving us indication how our 110-foot wingspan is doing with obstructions. Also during engine start, he could be standing up there and watching the engines, seeing if we're too rich, too lean while we're trying to get the engines running. So as we come down out of the cockpit, we have some additional equipment under the forward compartment. This stairway lifts. On this aircraft, we have the brake accumulators on the left and right. On the in military, during the war, they had an auxiliary power unit there, and you can even see where the exhaust port is, that little finned area off to the left, that circular area. We have our batteries under here on the left and right, and electrical junction boxes. Of course, when the nose gear is up, it fills that compartment. And the only way for the bombardier, the nose gunner, and the navigator to get forward would be in this very small area along the right side of the nose gear, or prior to flight, getting up through the nose gear doors and crawling out there. So it's rather cramped when you had 3 men forward. They started getting into the D models, which was the first big production batch. All of that had to be reconfigured because they had the forward turret here. And the radio operator, instead of being behind the wing, sat at a little table right here in a very cramped position. The flight engineer, who was right behind the pilots, was also normally the top turret gunner. So they had multiple duties. Right above us is the bottom of the wing, which is also the fuel tank, as it is in most aircraft, or many aircraft. Unfortunately, in this one, it's within the confines of the cabin, so if you, in battle, if you had any damage to the wing, it'd be very common to get fuel vapors in here, and more than a few aircraft were lost to that. The bomb racks in this aircraft are essentially authentic, but their positioning is not. They should be much closer together, particularly at the bottom. They would typically be about 7 inches wide at the bottom. We have them in here so that we can hang replica bombs on them, but we have them spread wide so that you can actually move passengers back and forth. And our equipment, we of course have a lot of equipment in here at the moment being on tour. But the bombs are on shackles, and those shackles are released in a sequence, and the bomb bay doors would come up along the side and allow the bombs to go out. Now, this particular aircraft came out of the factory with bomb bay doors like every other B-24 bomber, but it was damaged in a training accident, and rather than just repair it and send it out to battle, they decided to modify it to become the prototype for the C-87 LIberator Express, which was a cargo passenger hauler, and that's how it was used during the war. They had windows along the sides, no bomb bay doors, and then later it became a corporate aircraft with a very pristine, very functional corporate livery in the cabin for essentially 20 years. And then slowly over time, we've been configuring it back to near what it was like coming out of the factory in 1941. The aft portion of the Bombay varied a great deal depending on the model of aircraft. The early B-24s through the D model had just regular equipment at this location, but you got into the J models, and here would be a large retractable ball turret for the gunner below the aircraft. So we can see from our sign, this is the radio operator position, but that was mostly on the early aircraft, although there were some other models that did have the radio operator back there. The gun position, it's kind of hard to visualize. We show it here in a poster. You can see the men here in their leather flight suits, helmets, flak jackets, standing back to back. We have the gun window here, and of course there was a gun window on the other side. Those windows were open during flight and would be extremely cold back here. We'd have a 50 caliber machine gun, of which we have a replica. And that gun would be positioned out the window. And of course the 200 mile per hour wind can make it rather difficult to aim. This position is best represented by this poster. You can see the gunner is sitting on the floor. And he has nothing but side windows and a plexiglass below to watch a fighter go zoom by. And we have the 50 cal in. We've got a bit of netting up there to support the gun. But the 50 cal and the plexiglass is there, much as it was when it came out of the factory. So in the rear of the aircraft, a couple of things stand out. One is it's very basic, no protection whatsoever from flak. We have the overhead wires, which are the cables we saw from the elevators and rudders. And as we get to the back, we have a single 50 caliber machine gun with nothing but a sling to sit in. Very soon after this model, the D models would have a turret back there where the gunner would actually sit in a turret and have twin 50 cal. So we had better firepower, a little more protection, and it was just a better arrangement. So this sling and the open windows give you a real view into the world. But of course, when you're shooting out there with this great view, the other aircraft has a great view of you, so it's not a great place to be sitting when you're seeing a fighter out there with some little sparkles coming out of his gun. So this entrance door, of course, is new. It's for passenger use. When the aircraft was first reconfigured after the initial landing accident, this doorway was put into place, but it was a swinging door. Made it easy to load freight and so on. But Gary Austin designed this air stair, which has worked very, very well. We have still a few plexiglass windows in the aircraft that are best used for a flight engineer to come back and view the aircraft, engines from the rear, and to see if the landing gear downlock is shown.
Is there a visual signal when the gear are locked, like a colored panel that pops out?
Gear downlock is a yellow protrusion. Unfortunately, it goes between two yellow lines, and it is far from easy to tell that it's a line between the two. So it's a little difficult to really determine it. These tires at $4,000 a piece with a $400 tube are identical to the tires, brakes, and wheels on the B-29 and on the B-17, which helps because we have to order them in mass in order to have any type of a production and be able to use it. We have 4 Pratt & Whitney 1830 engines, 1,200 horsepower. Notice that these cowlings are round. Almost all B-29 photographs you will see, you will have an oval cowling because they were turbocharged. So the external oil cooler we see here would be within the cowling on one side, the turbocharger pre-cooler would be on the other. So, very different look than these. But the very early model of the aircraft did not have turbochargers. So this is authentic to the way this aircraft came out of the factory.
How much power did the turbo add to the engine?
Great question. I keep seeing 1,200 horsepower no matter where you're looking. I think the biggest thing is that at higher altitude you would continue to maintain 1,200 horsepower. Whereas normal aspirated engines, as you get higher, for every 1,000 feet you lose 1 inch of manifold pressure. And at a certain point you don't have enough power to keep climbing. If you turbocharge, you can go higher. A couple of things about this. The cowling, first of all, you can see cowl flaps coming out. It's used for cooling. And the engine, the oil cooler, it has no controls for temperature. It's preset, and on hot days it can be an issue. You see some oil dripping off. Radial engines, just by design, drip a certain amount of oil. These Pratt & Whitneys are very tight engines in that they drip very little oil, as opposed to our B-29 Wright 3350s, which will have oil a great deal more. Of course, they're bigger engines as well. But one of the reasons is that the tolerances on an air-cooled engine need to be less precise, less tight, so that as temperature changes, you don't have a problem with insufficient clearance within the cylinders and so on. So it is normal for a radial engine to drip oil afterwards. We have 30-gallon oil tanks for each engine, and we'll typically use about a half a gallon of oil per hour per engine. Diamond Lil, the nose art here is fabulous. We just love it. Let's point out a couple of things. This aircraft was originally painted as Diamond Lil when the CAF first got it from Mexico, or very early on. So you'll see a lot of photographs of the early Diamond Lil. And it was a little bit different rendition. In this rendition, we see a little B-24 charter bracelet, we see the CAF logo on her bracelet. Beautiful gal. Gary Valesco painted this in 2012 after we had a couple of years of a logo that said Old 927, which is how the aircraft was referred to during the war years. And what the sentiment was within CAF and around the warbird community that this was Diamond Lil, and we're thrilled to have this gorgeous rendition of it. She's a hit. You know, people love to have the photo taken with this nose art. So what we call the greenhouse, there's several different versions of this on various models. This being an A model, has a single 50 cal and has a Sperry bomb sight, which is unusual because very soon into the production they went to a Norden bomb sight. So the bombardier sat up here as well as a gunner, even though they could do each other's duties depending on the circumstances. Behind them, sitting backwards at a small plywood table, would be the navigator. He was basically at the feet of the pilot. And all he had to look out was over his shoulder window there, or the small side windows. Also, he had a small bubble at the top for taking his sun shots and star shots for his navigation. So it's amazing the amount of work that a navigator had to do, the amount of skill, I should say, that they had to navigate these aircraft across the continent, across the Pacific, across great distances. We'll note that on the right side of the nose is a flag. First of all, people look at that and say it's a reverse flag or it's a backwards flag. However, it is designed to show the representation of the flag as if it was on a pole in flight, which of course would be flying backwards. If you look above to the American flag on a pole, you can get some idea of that. Even on today's modern airliners, on the right side of the tail, you'll often see an American flag with the same orientation. But it does look unusual. This flag is actually painted for a specific purpose. It is called a neutrality flag. There was a similar flag out on top of the aircraft fuselage. And that is because these first aircraft in 1941 were being shipped to France and England during a time when the U.S. was a very isolationist country and was not yet at war. There were no armaments. You could not see the guns sticking out of the aircraft. And as these went across the Atlantic, this flag was to indicate we're not a target. Don't shoot us. We're a neutral nation. Of course, when December 7th happened and we declared war on both Japan and Germany, we very quickly dispensed with the neutrality flags and went to war with these aircraft. So we see an example here of a relief tube, which it's interesting in design in that it's a venturi with air coming in here to provide a bit of suction so that it functioned as you would hope it would. Long missions, you had to either use a container or a relief tube to take care of your personal needs. In the aft portion of the aircraft, the empennage, we have the vertical dual stabilizers and rudders, as well as the horizontal stabilizer and elevator. Those control surfaces on the far end, the rudder and the elevator themselves, are covered in fabric. It used to be a cotton fabric, and now it's something a little more durable. But the reasons for that were several. One is that they were lighter. The aircraft overall, the structure is aluminum. The empty weight of this aircraft is around 30,000 pounds, which sounds like a lot, but remember that you have 4 engines on there, each of which weigh probably 1,500 pounds apiece, and you have a lot of structure here. But it's a type of aluminum alloy, duraluminum, that is reasonably strong for its weight. Hi, I'm Benzing, the aircraft commander and pilot of the B-24 LIberator, Diamond Oil. Commemorative Air Force invites you to join us